Okay, so hello guys again. We're gonna continue the triangle congruency for today. And then before we start our new like what do you call chapter, let's get review for last time's knowledge. And so today we're just gonna take turns. So Alex, William, and then Ethan. Okay. So just like take turns of you guys. So let's get started with Alex. For like 7 and 8, and then you guys can do practice with them for 9 and 10. So
All right, okay, so today we're going to go over some basic angle relationships, and right here at 7, we see an example of corresponding angles. Now note that these two lines with the double arrowheads at the end are parallel. You must always have a set of parallel lines and a transversal line, which is what forms angle A and B, in order to have this relationship. Now, as we see here in 7, the corresponding angles A and B are congruent, which means that A and B have the same angle measures. Now, in 8, we see another example of another angle relationship, and this is called the alternate interior angles. Basically, you have another set of parallel lines cut by a transversal line, form two angles B and A. And notice how they're alternating on the different sides of the transversal. This is how we know that they're both congruent. So B and A are alternate interior angles, and they are congruent.
cool. And you guys can do 9 and 10 by yourself. We'll give you guys like 1 or 2 minutes. 1 minute is enough, I think. So and then William, you can like continue, and then you guys can take turns for today. I'm gonna like leave Zoom for like few seconds. No. You guys can take turns like right now. So
All right, so in number 9, we see another relationship called alternate exterior angles, where A and B are formed by a set of parallel lines and another transversal cutting through them. Now we see here that A and B are different from the B and A in 8, because for one, the B and A are interior, they're inside the parallel lines, while A and B in number 9 are outside of the parallel line. So this is how you should remember them, but just know that alternate interior, alternate exterior, these angles are all congruent at the end of the day. Now at 10, we see another example of corresponding angles, A and B formed by the transversal cutting through a parallel line. So that's just another case of 7.
wait. Can William or Alex share their screen so you guys can control it by yourself?
I'll share.
Sure. Thank you.
Okay, so more about angles. There's a special angle called the right angle. It's just an angle whose measure is 90 degrees. Complementary angles are a set of two angles whose sum is 90 degrees. So two angles whose measures add up to 90 degrees. And supplementary angles are a set of two angles whose sum is 180 degrees. So basically two angles that make a straight line. And the fourth term is adjacent angles, which is two angles who share a common vertex and side but do not overlap. So for example, here in this first one, angle 1 and angle 2 are adjacent angles. They are adjacent angles because they are next to each other, meaning they share the same line right here, but they do not overlap each other because they stop right where the next one starts. So they are adjacent. Let's see. If we look here, this angle, we can call that BXC, is complementary to this one, which is CXD. Because we see here that this is a right angle, and so this side also forms a right angle. A right angle is 90 degrees, and these two make up what is 90 degrees, so they are complementary. And then we see this one over here, angle AXD. Angle AXD is supplementary to DXC, angle DXC, because they form a straight line right here. And AXC would be the 180 degree angle.
So name the angles relationship. I'll give you guys 2 minutes to do these questions. Yeah. Okay, so I'll name the angles right now. So for number 2, it's supplementary angle. Wait, how did you change the font? Okay, so for number 2, it's supplementary angles. For number 4 is how to spell complementary? Complementary angle. Is that how to spell it? Okay. And for number 6, it's adjacent angles because this one they're not forming 90 degrees because I mean you can tell it doesn't have the red thing over there, so it's not right angle, so you can't say that they're complementary angles, so they're only adjacent angles. And for number 5, the AB part the AB part is complementary angles, and the red part, which is this part, like here, this one is right angle because it's angle. Because, oh, wait. angle. Because it's forming 90 degrees. Yes. And for number 2, AB, there are supplementary angles because they're forming 180 degrees. Yes.
All right, I'll give everyone about 4 minutes to do these problems. If you can't do it, that's totally fine. I'll show everyone the solutions after the 4 minutes are up. You want to find the measure of angle B. So just remember all the angle relationships that we went over, supplementary, complementary, all of those. All right, I guess I'll go over problem number 17 first. All right, so from a glance at problem number 17, we know that B and the angle with the measure of 46 are related by vertical angles because they're formed by two lines. So there's a line over here and a line over here. And remember that the angles formed by two intersecting lines are always congruent. So this is how we know B is equal to 46 degrees. Okay, problem number 15. It may not be obvious at first glance, but we can extend this line over here, or this ray, into a straight angle. Now, this may look like a line, but not an angle, but remember that a straight angle is just a line with an angle degree measure of 180 degrees. From this, we can see that B, the angle B plus 39, is supplementary with this right angle over here. So that means B plus 39 is equal to 90 degrees. So B and 9 are complementary angles. So this gives us B is equal to 51 degrees. Now in 16, we see that B and 85 are related by the alternate interior angles because there are two parallel lines. I'll denote this as line L and line K. Line L and line K are transversed by this line N over here, which results in B being congruent to 85 degrees. So B is equal to 85 degrees. Now here in 12, again, we have lines L and lines K cut by a transversal N. So we know that the angle B and angle 60 are alternate exterior angles. So B is congruent to 60 degrees. So B equals 60 degrees. Now here in the final problem, we see that 65 and B make up a right angle, not a right triangle, make up a right angle. So we know that 65 and B are complementary. So B plus 65 equals 90. So B is equal to 25 degrees. I'll leave that on there for a bit for you guys to copy, and then we'll move on. All right, if you guys didn't get that, it's fine. You can go back and pause, but I guess we should move on to the next slide now.
All right, now we're past angles. We've learned all that we basically need to know about angles for now. And what we're going to go into is triangles, triangle congruency. So what does it mean for two triangles to be congruent? It's the same thing as saying two angles are congruent. They are basically identical. So there are 5 ways to prove that two triangles are congruent. So here are the abbreviations. The first one is SSS, SAS, ASA, AAS, and what is here says RHS. So the first one, SSS. Each S stands for a side. So for example, this side, which we see right here, the longest side is corresponding to this longest side on the second triangle. These 2 tick marks here, which you see across both sides of the triangle, mean that these 2 sides are congruent. So their lengths are equal. If two line segments are congruent, then their measures are equal, okay? If the 2 line segments are congruent, then they're the same length and their measures are equal. And SSS, if you have 2 triangles where all 3 of the sides are congruent or equal in length, you can then say that the 2 triangles are congruent or equal. The second way to prove congruent triangles is by SAS. Now remember the S stands for sides, so there's 2 sides that are congruent, and the A stands for an angle. That means there's one angle that is congruent. Notice the order the letters are written in. SAS means that the angle is in between the 2 sides. That means the angle is the included angle of the 2 sides. So if we look at the picture here, the first one has this side congruent to this one, and this side congruent to this one. And the angle that is in between both the sides here are also congruent. If, for example, this angle was congruent to this one, it's not SAS. You cannot prove that those 2 triangles are congruent. In fact, they are not congruent, but you cannot prove they're congruent because one is the included angle and the other one is not the angle in between the 2 sides. And the third one is ASA, congruence theorem. So ASA, remember the A stands for an angle and the S stands for side. So it's 2 angles and 1 side. And again, the order matters. So the side has to be in between the 2 angles. And as we can see from the diagram, one of the angles, these 2, and then the other one is these 2. And the side, which is in between the 2 angles, is this one, right here. This side is congruent to this one. And then we can use as ASA to prove that the two whole triangles are congruent. Then there's a fourth one. So this is also very similar, two angles and a side, but this time the side is not the included side. So we can see here that this is one angle, this is one angle, this is one angle, and hold on, and this is another angle, and the side is not this one. These two are not what's given congruent. Instead, the side that is given congruent is this one right here. This side is congruent to this side. So here we use AAS congruence to prove that the two triangles are congruent. And finally, one special one is what they call RHS, which basically you don't need to remember the name for this one. There's a lot of names it goes by. Sometimes it goes by HL congruence or otherwise. It's for right triangles only. Okay? So a right triangle is basically any triangle that has one right angle. No triangle can have more than one right angle, only one right angle. So any triangle that has one right angle, which is 90 degrees, is what we call a right triangle. And we can use this theorem right here to prove right triangles congruent to another right triangle. So we can see here that the lines that are marked congruent are this one to this one, and this shorter one to this shorter one. Now, I'm not sure if you guys learned this before, but the longest side of a right triangle and the one that's opposite of the right angle, so in any right triangle, if this is the right angle, this side right here is what we call the hypotenuse. I'll type that since. So this side right here is called the hypotenuse. And each of these sides down here are called legs. This is a leg and this is a leg. So the hypotenuse is the side that's opposite the right angle, and legs are the other two sides. One, we have to have the hypotenuse congruent. That's one of the sides that should be congruent to use this way of proving the triangle is congruent. The hypotenuses are congruent. And then either one of the legs. You only need one, but if both are congruent, then it's also congruent. But you only need one leg. And in this case, it's this one here. These legs are congruent, along with the hypotenuse being congruent. The hypotenuse has to be congruent. And then you can prove that the right triangles are congruent. Again, they have to be right triangles. Now, the last one here is not sufficient for congruency, which means if you have two sides and a non-included angle, and it is not a right triangle, if it's not right triangle, then two sides and a non-included angle is not enough to prove that two triangles are congruent. So for example, or just to show you why, if you see that you have a triangle with a side length of 6, a side length of 11, and a non-included angle, for example, 30 degrees, you can extend this side out right here, and you can see that the side opposite the angle measure given can intersect this line at two different points. That means there are two possible angle measures for this angle right here. That's why given two sides and an angle, that is not included. You cannot prove the triangles are congruent unless it is a right triangle. That's the special case right here. And that should be pretty much it.
So for this one, you can see that they are all congruent, and this one, the one on the left is by wait, okay, you can see that like this one is congruent to that one, this one is congruent to that one, and this one is congruent to that one. So this is say side, side, side problem. Okay, so you guys can pause the video for the one on the right, and when you guys finish, you can resume the video. So I'm gonna explain it now. Okay, so these two angles are congruent by SAS. S A O A S. Okay, so you can see that the 5 is equal to that 5, and 4, and I have the same angle of 100 degree right here, and the other side, which is right next to the 100 degrees, also for both triangle. So we can use SAS to prove that these two triangles are congruent. Yes.
You guys can go to the next slide.
All right, so here are 9 problems to help you, I guess, reinforce your knowledge of the angles. I'll give you guys 5 seconds to pause, and then afterwards, I'll explain all 9 of these problems for you guys. All right, I assume you guys are all back from doing the problems. So let's first look at number 1. Now here, when we look at number 1, we initially only see 2 pieces of information given to us. That side FG is congruent to side GH, and that angle FGI is congruent to, wait, no, that's not given to us. We see that angle FG is congruent to, not angle, side FG is congruent to side GH, and that side GI is congruent to itself by something that we call the reflexive property. So the reflexive property. Now this sounds complicated, but in reality, it just means an object is congruent to itself. So over here, we can see that through HL or RHS congruency, that triangles FGI is congruent to triangle HGI. Okay, problem number 2. We have more pieces of information over here. We see that NQ is congruent to NO, that OP is congruent to QP. And as always, MP is congruent to itself by the reflexive property. So triangles NOP is congruent to triangle NQP through SSS. I'll just write it down here. Now here, in question number 3, we have a bit of work to do. The first thing that we should know is that BCA and CED are both vertical angles, that they are congruent. Now, because that we know that they are congruent, we can now determine that these two angles are congruent because ABC and CED are congruent, and BC is congruent with CE. So we know that 3 is congruent through angle side angle congruency. Now, number 4, we see that these two triangles share a side through the reflexive property. So that's a side. They share an angle over here, and they share another angle over here. So this is related by the angle side angle congruency. Now, question number 3, it's the same idea. We have a side shared by Km, so that Km is congruent to itself by the reflexive property. Kjm is congruent to Klm, and Kmj is congruent to Mkl. Now, if we do some more work, we find that Kml is congruent to JKM. Now, through this, we find that triangle KJM is congruent to triangle MLK through angle side angle because of these angles in this side. So this is congruent through angle side angle congruency. Question number 6. We again see the same property where MP is congruent to itself by the reflexive property. Again, this is a very important property that you should memorize, but it's very self-explanatory. And we see that QPN is congruent to ONP, and that NQ is congruent to NO. So this tells us that triangle NQP is congruent to triangle NOP through SAS congruency. Now in question number 7, we see the same idea in question number 3, where in BCA and ECD are vertical angles, and that these two angles are related to each other by angle side angle. And this is because since we know 2 of the angles in the triangle are congruent, we know that the third angles, which are ABC and CED, are congruent because all the angles in the triangle add up to 180. So we know that this is also congruent by ASA congruency. Now in question number 8, we see that GH, once again, is congruent to itself through the reflexive property, and that FGH is congruent to HG, what is that? That looks like a lowercase h, or an I suppose, through the angle. So angle FGI is congruent to angle HGI, and angle FIG is congruent to angle HIG. So we know that these two triangles again are congruent by angle side angle congruency. Now number 9, again, we see the same property. KM is congruent to itself through the reflexive property. KJ is congruent to LM, and KL is congruent to JM. So here we see that the two triangles are congruent to each other by SSS congruency. Now you can pause for a second to make sure that you have all of these correct, and then we'll move on. All right, I guess we should move on to the next slide now.
So congruence reasons. Let's see. We see here what Alan was talking about earlier, the reflexive property without the T. The reflexive property, a line or shape is congruent to itself. Now, line or shape, and you should add angles as well. Angles are congruent to itself. So let's see, what are some examples we can look at here? If we look at line F, I think that would be I. Line FI, line segment FI, would be, by the reflexive property, congruent, and this is the congruent symbol, to itself. It's basically the same as saying it's equal to itself, right? 2 of the same numbers are equal to itself, and the same line segment is also equal to itself. And then we can see, okay, if we call this point right here, this is the point right here. If we call this, for example, T, we can see that FTS, which is an angle, would be congruent by the reflexive property to itself. Okay. All right. Next is what we call midpoint. The exact middle point, that's a weird way to explain it, but so the midpoint of a line segment is the point which divides that particular line segment into two congruent segments. So for example, let's look at the segment SH. SH, and this is still just T. This point is still T. Okay. T here would be the midpoint of SH. So if I were to write that out, T is the midpoint of SH. Right here. T is the midpoint of SH because we can see that the segments ST and TH are congruent. They have this little tick mark through them, which makes them congruent. And the midpoint is defined to split a segment into two equal halves or two congruent halves. They're pretty much the same thing, right? So T would be the midpoint of SH. Next is what you call perpendicular bisector. I think it'd be better to split this into two parts. The first part is perpendicular and the second part being bisector. When two lines are perpendicular, they intersect to form what's a right angle or a 90-degree angle. Those are the same things, right? So if we look at the lines FI and the lines SH, line segments, sorry, FI and SH, they are perpendicular to each other because they intersect each other at T and they form a right angle right here. Okay, so the way you can write that in shorthand is draw this symbol. This symbol means perpendicular. Fi and Sh form a right angle when intersecting with each other. Now, one thing to note is that all four angles would be right angles. Because Sh is a straight angle. A straight angle is 180 degrees minus a right angle would create another right angle. And it's basically the same thing for the rest of the angles as well. So all four of the angles made by two perpendicular lines would be right angles. And finally, the second part of what is being said here is bisector. That means one line is crossing through the midpoint of another line segment. For example, here, Fi is the bisector of SH. So it bisects SH. Why can we say it does that? We know that T right here is the midpoint of SH. Fi passes through T, which makes Fi split SH into two congruent parts. Therefore, Fi is what we call the bisector of SH. Now, to combine the two things we learned together to make the perpendicular bisector. A perpendicular bisector is a line segment or a line that splits another line segment into two congruent parts, meaning it bisects that one, and it is also perpendicular to the line segment, which is what is shown in this diagram right here. It passes through the midpoint T, and it forms a right angle. So Fi is the perpendicular bisector, if I write that out. Fi is the perpendicular bisector of SH. Note that the second part of a perpendicular bisector, the line segment that is being bisected, must be a line segment. It can't be a line because a line is infinite. All right. Now we can look at the last part. This one is complicated. Okay. CPCTC is just shorthand. So if you don't memorize that, that's fine. You just need to understand the concept. Congruent parts of congruent triangles are congruent. That could be a little confusing, so I think if we draw triangles here, it might make more sense. Okay, so if we draw a triangle here, and we draw a triangle here, okay? And then we label our point right here, T, as always. We can show CPCTC. Okay, first we need to prove that two triangles are congruent. That is what this CPCTC is used for. When two triangles are congruent, and here the triangles would be triangle FT, bad handwriting, triangle FTS is congruent to triangle FTH. Okay? And FTH. These two triangles are congruent. Why? We learned this earlier. Look right here. The reflexive property means that a line is congruent to itself. FT is congruent to itself. And you can mark that by just drawing an X, two diagonal tick marks, whatever you want to call it, over the line segment that's congruent to itself. FT, I'll write it up here. FT is congruent to itself. Okay? We see that ST is congruent to TH, as marked on the diagram, and it's the definition of perpendicular bisector, which we also learned earlier. Right here. And we know that FTS and FTH, the angles, are congruent because they're both right angles, and all right angles are congruent to each other because they have the same measure, and that's the definition of congruent angles. So we know 90 degrees, 90 degrees. So therefore, the two triangles are congruent. And once you know that the two triangles are congruent, let me just erase this. Once you know that the two triangles are congruent, you can then say that okay, this is wrong. This should be corresponding. This should be corresponding. I'll type it out. I didn't notice the first time I read it, sorry. A lot of errors. So this right here, that's not the best way to mark it out.
I would change it right now. I would change it right now.
Oh, okay. Once you change it, tell me, I'll reload. Okay, so we can cross this out for now. It'll be fixed in a bit. But this is corresponding parts of congruent triangles are congruent, not congruent. Okay, so here, we know that the triangle FTS and the triangle FTH are congruent. Oh, and I don't know if we mentioned this before, probably not. The order you write the letters matter. Okay, so let's talk about what we mean by corresponding first, and then I can describe. Okay.
Reload it right now. I have
Yeah.
just change it. Yeah.
How do I do this? Hold on. Yes. Okay. Good. Nice. All right. Back to what we were talking about. Let's talk about what corresponding parts mean. So corresponding parts mean in two triangles. We can just take this triangle for an example. We can look at this angle right here and this angle right here. If we call these angles, for example, just angle 1 and angle 2, right? These two angles are congruent to each other. They are congruent to each other because they are the corresponding parts of these two congruent triangles, the two congruent triangles that I wrote on the bottom here. they are corresponding parts because they match up to each other. So we know that if triangle FTS is congruent to triangle FTH, then TFS, or angle 1, we can write it here, is congruent to angle 2. Because the triangles are congruent, the matching angles are congruent. And it would be the exact same thing for all the other angles. Now, here's why I say the order you write the letters matter. Because this determines which angles are corresponding to each other. So if we look here, the first letter in the first triangle, I can use a different color. The first letter in the first triangle is F. And the first letter in the second triangle is also F. Which means that the point F right here is corresponding between the two triangles. That means the angle 1 and the angle 2, which have F at their vertex, are the corresponding angles. Next, we can, for example, look at T right here. I think it'd be easier if I did this. Wait. Aha. Next, we can look at T. They are both the second letter when writing out the congruence for the two triangles, which means they are corresponding. And the angle that's formed at vertex T, this is a bad color. The angle that is formed at vertex T here and in the second triangle are corresponding, and therefore they're congruent. And finally, how many times that? Okay. Finally, we look at the third letter, S, and the third letter, H. It's the same as before, except they're just not the same letter anymore, but it's the same as the previous two times. The S is corresponding to H in the two congruent triangles, which means the angle at the vertex S is congruent to the angle at the vertex H, right here. So we know that this one is corresponding to this one, which by the theorem we're learning right here, CPCTC, they are congruent. Now the same thing works for the sides. It's actually slightly easier to visualize. I'll just erase this. It's a bit of a mess. Okay. Now we can look at the sides. Corresponding parts, they do not have to be angles. Sides work as well. Now, if for sides, we look 2 letters at a time. If we look at the first 2 letters, FT, and the second 2 letters of this one, FT, we see that FT, this side, is corresponding to FT, the side of the other triangle. By CPCTC, they are congruent to itself. Now, here's where we can check that this theorem actually works and we're not just making this up. Because FT is congruent to itself by the reflexive property, because it's the same line. It's the same line segment. And by CPCTC, you can also prove that FT is congruent to itself, because they are corresponding sides of 2 congruent triangles. And then it will be basically the same thing for the next 2 sides. Again, looking 2 at a time, TS and TH. These 2 are corresponding. And we can see they're right here and here. They're marked congruent, right? But if they weren't, and we were given that the 2 triangles are congruent, we can also prove they are congruent sides because of CPCTC. And finally, arguably, the trickiest one, because you can't draw one line. F, S, and F, H. They are also corresponding. Remember, there's 3 sides to a triangle, and this would be the 3rd side. FS is also congruent to FH because they are corresponding parts of congruent triangles. their vertices are match up with each other, so their endpoints, match up with each other, so they are congruent. Now that's a lot of information, so I think you should pause for a few seconds if there's something you don't understand, and we will have some practice problems afterwards, I hope, as well. I'll leave this up for like 2 more seconds.
Yeah, so make sure you like write your notes, whatever, where you take a screenshot. And then I think then, yeah, go ahead.
So make sure you understand thoroughly what corresponding means and what it means to be they have to be parts of congruent triangles. This is very important. If the triangles aren't congruent, this theorem doesn't matter. So those are the two things.
And if you're like confusing, you can like go back, return to restart, and then rewatch it. Yeah, and then I think we can finish today's lesson right here, since there's a lot of information today. And then, yeah, let me pause the recording real quick.
Describe an event like I celebrated the festival, which is blah blah blah, which is, for example, I celebrated Christmas, which is kind of a great festival for the Western countries, and whom just for not if you are not that confident in using it, just just do not use it. But I believe if your teacher is not that strict, he or she will also will accept both whom or who. The boy whom you told me about got the best grades in mathematics. So because the boy is told by you, the you mentioned in the sentence, it's not actually you, it's the you in the sentence. It's kind of like being passively told by someone. So so you use whom, and that to describe a subject or object, noun, pronoun for people or things. Like it's really kind of it's kind of great that it can be used to describe almost everything. Like I like the vase that is over there. And where is to referring to the place, like the restaurant where I usually have dinner is nice. When is to refer to a time. Like there are times when I feel so lonely. Um, why? And it's to referring to a reason. And so as I mentioned before, which and that they are kind of omnipotent. Which is to say they can be used they are useful in almost all the situations, but to be to be academic, um when you use them, it's not you cannot use them that casually. So here are the difference between which and that. So when you usually use that, you don't add a when you usually when you are using that, you don't usually add the comma before that. So comma, like this is a comma. So you don't usually add a comma before the word that. So that sentence using that, like for example, they caught the lady that uh wait no uh like for example, this sentence, I'm sorry for the event that killed him. Um, so in this sentence, there's no comma before the that. But if you use which, especially when you are describing or when you are inserting the which clause into in the between of a sentence, in the middle of the sentence, you usually need to add a comma. For example, the event, uh, no, for example, the room which used to which he used to live in, um, the room which he used to live in is empty now. So here we add comma before the which clause, and after the short sentence we insert. So this is the first difference between that and which. So remember, you usually don't forget to add a comma before which in some specific situations, and we don't usually add comma before that. And also, you can really use which to refer to when or where. So, for example, the example I told you before, it has a little mistake. So the room which he used to live in is empty now. It's a little kind of uncomfortable to hear this sentence, but so it would be better if I say the room in which he lived is empty now. So you will mention that I moved the in the living to the front of the sentence, which is in which. So if you use in which, you can use in which to substitute the word where, which introduced the to refer to a place, and also you can use which to refer to when. For example, like if you are speaking normally, you say I ate the lunch on um I ate I ate the lunch on the morning. You can also say blah 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 the morning on which I ate lunch. So so remember on which you can use on which to substitute when. And also like if you use which like really sophisticatedly you kind of nothing will happen, but those people will respect you when you know that when you know so many uses of which. Um, we'll continue. We'll continue. Like there's a difference between the subject, if it's a pronoun or object pronoun. So, for example, the apple which is lying on the table is sweet. The teacher who lives next door is nice. So so this is basically saying that if the thing you're describing is a human, is a person, you use who. But if it's an object, it is not a living thing, you use which. And also, in some situations, you can just omit the which or that or whom. Like you can just omit them to express the same meaning. For example, the film we watched yesterday was fantastic. The film which we watched yesterday was fantastic. The writer we met last weekend is very famous. The writer who we met last weekend is very famous. So in this so for this clause, there's one situation like object relative pronouns can be omitted in restrictive relative clauses. This sounds not like the language you can understand. Just remember that if you are saying like an object or something, and then you say you did something to this object, you can omit the introducing word. But just be careful because not like like you also cannot uh like casually use this kind of sentence in every situation. And we're now talking about non-restrictive relative clauses like gives interesting additional information which is not necessary to the meaning of the sentence. So like Martin Luther King, who was known for his fight for the civil rights, was assassinated in 1968. We can just say Martin Luther King was assassinated in 1968. It doesn't affect the main thing you want to express because the main thing is that this one uh did this thing. So you can simply understand it as you can casually insert a small sentence to describe something using who, when, which. So I think that's pretty much for the relative clauses. Um, Alan, do you want to continue?
Yeah, give me a sec. Okay. What are irregular verbs? The difference between regular and regular verbs is that a regular verb follows a typical pattern in its conjugation. So conjugation is like how it's manipulated to make sense in the sentence, like tense wise. Like for example, verbs such as close, live, watch, visit, and play are regular. They consistently take s, ed, and ing in the simple present, past simple, past participle, and present participle. Check the following chart. So here, the infinitive is just like the normal verb. So you have close, live, watch, visit, play. And simple present, so you just add an s at the end or es depending on the verb. Simple past, you add an ed. Past participle, I think it's the same thing as simple past. And present participle, you add an ing at the end. Irregular verbs, on the other hand, don't follow the above pattern. They are inconsistent in their conjugation. Their simple past and past participles have different endings. See the chart below. So here you have the infinitive come, cut, do, go, speak, spend, write. And the way they're conjugated is different from regular verbs, and it's not always the same. So simple present is still the same. You add s or es, but simple past and past participles are different. So see here, it says came, cut, did, went, spoke, spent, wrote. None of them are really the same, I guess. I mean, they don't follow a similar pattern. And same with past participle, come, cut, done, gone, spoken, spent, written. Again, not the same. And then present participle, adding an ing again. But it's simple past and past participles are the ones that are different. Since simple past and past participle forms of irregular verbs are unpredictable, they have to be learned by heart. You just have to know them. Yeah, here's a list of them. So yeah, it's pretty long, but like it just comes naturally if you keep practicing, I guess. Yeah. Let me see. Let's do an exercise. So choose the correct answer, as or like. So I think this is different. Okay, so basically as or like are two like they're like kind of comparing words, I guess. And when you say like, it's usually like what I'm doing right now. You're comparing it to something, and then as is, it'll make sense once you look at the sentence. So if you say she looks blank like her mother, is it she looks as her mother or like her mother? So the answer would be like her mother. Yeah, actually, there's a lesson here. What is the difference between like and as? Like and as are confusing for many English learners. In this section, we'll try to show how they are used in specific examples. So as is a preposition or conjunction. It can function as a preposition and is used when talking about a job or function. So for example, I worked as a taxi driver. He was nominated as Secretary of State. He used the carpet as a decoration. As may also be used as a conjunction, meaning in the same way that. She behaved exactly like her mother told her to. When in Rome, do as Romans do. Like is also a preposition or conjunction, but it means, as a preposition, it can mean similar to compare things. He has been working like a dog. I am like my mother. He looks like his father. Like is often used in the subordinated conjunction as or as if. They look like they have been having fun. They look as if they have been having fun. So this basically just means they're like the same meaning, but different words. So if we go back, so she looks blank her mother, like would be the correct one. He was appointed, so for a job, right? You would use as. Comparing something, she's comparing this girl to an angel, so like. Blank, I told you before. I mean, like and as would both work, but as is usually the correct one in this kind of situation. Comparing your brother to me, so like. Oh, that's my name. Alan qualified blank as an engineer, so a job again, right? As. He works blank as slave to get the project ready, comparing him to a slave, like. She can swim, so she compared to fish, like again. Seems, not this one both can work either again. Seems as it's gonna rain, seems like it's gonna rain. Oh, as if. Well, actually, no. This is as if. So if there wasn't an if here, both would work. But since there's an if here, you have to use as if. She did the work like she promised. I don't think as would work here. As you can see, comparing her to a princess, as it was expected. He ran like, right? Comparing him to lightning. Don't behave. So there's I think there's like an implied you. I think that's what it's called. And that implied you is being compared to child. Story compared to this one. Can you be as compare, like this one's like comparing what's it called? Like comparing, I don't know how to explain, but yeah, as is the correct answer here. It seems like like as if, right? Because there's an if. He looks very much like his grandfather. I don't like roles like the one, roles compared to one, as you can imagine. So usually if it starts off the sentence, it's as. She looks like a superstar, right? Also, like if like a noun comes right after it, it's typically like a you use like, right? Here, her mother comes right after it. Angel, me, slave, fish. I don't know. I want to join the company as a manager. I hate mean people as much as comparing, like, this is like a measure, like how much, right? Here's some tips on how to write like a professional, writing like a professional. So let me see if I got them all. Oh, I missed this one. Okay. So as she promised would be the correct one here, because there's I mean both would basically work. Yeah, I mean it's debatable. So yeah. Yeah, that's basically it.
Okay, so here are some exercise on relative clauses. So the first one, this is the man, blah blah blah, save the kid. Um, so so you can take some time just by pausing the video, and I'll just continue here. So there are three choices: who, which, whose. This is the man who saved the kid. This is the man who's saved the kid. This is the man which saved the kid. Um, so in this question, we choose who, because if you use which, we don't usually use which to describe a person, a human. So we eliminate which, but and we continue observing who or whose. When you are saying whose, like for example, this is the house whose owner is a landlady. Um, so if you are saying whose, the thing that follows whose should be something that belongs to the word it is describing. So 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 can you say save the kid belongs to the man? Obviously you can't. So you can only choose who. This is the man who saved the kid. Who is referring to the man. And we'll continue to the second one. The second one, the house blood windows are open is beautiful. Uh, you can take some time by pausing the video, uh, and I will continue. The house who windows are open is beautiful. The house which windows are open is beautiful. The house whose windows are open is beautiful. So we can also mm, we can also eliminate who, because as I said before, who is basically referring to a people, a person. So it should be a human before who. But the house is obviously not a human, so we can eliminate who. And then we will look at which and whose. Uh, um, so when you're using which, like we can use which to describe things, including object. So it seems like we can choose which here, but it doesn't make sense. You say the house which windows are open is beautiful. because it is always like uh like for the I'll give another example like the cat which plays which plays the ball is naughty. Uh, in this situation, we can split it in two sentences. Like the cat is playing the ball, and the cat is naughty. But here you can say the house is beautiful, but you cannot say the house windows are open because you know that misses something obviously. So there's only one choice left, which is whose. As I said before, the house whose windows are open is beautiful. So if you consider the windows are they belong to the house, it makes sense. So you can use whose here. So we'll move to the third one. The writer, blah blah blah, wrote the article won the Nobel Prize. So here we can just choose who again because it satisfies the condition that the thing it's describing is a human. The writer is a human, and then uh, and then it is followed by a verb. It is followed by you know a short sentence that makes sense if you split the sentence to two sentences. And then we'll move to the fourth one. He bought the car, blah blah blah, runs fast. So for who, you need to remember that it should be a human before who. But a car is obviously not a human, so you cannot use who. So we eliminate who and whose. There's no nouns after whose, so we cannot use whose. So we use which here. You can split it to he bought a car and the car runs fast. Uh, so for the fifth one, he was wearing a cap. Blah 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 was black. Uh, and we can probably assume that it is saying that he's wearing a cap, and a cap was black. So we can obviously it is the same with it's almost the same with the previous one. It should be which. And next we're gonna combine the sentences using the relative clause. First one, the lion is an animal. It's very strong. It is kind of an inverse process of splitting two sentences, splitting the relative clause sentence into two sentences. So here, uh, a lion is an animal, and it is very strong. So we can also say a lion is an animal, and this animal is very strong. So it should be a lion is an animal which is very strong, and which is referring to an animal, which is lion. Um, for the next one, a novelist is a person. She writes novels. This is probably using the same logic as the lion, so we'll just say a novelist is a person who writes novels. Because when you are using which, you usually don't describe a human, but if it's a human, it's a person, you use who. And the third one, a bottle opener is a device. It opens bottles. So here it is almost the same with, it is also almost the same as a lion is an animal. So we can just say a bottle opener is a device which opens bottles. And notice that here we can also use that because in this situation they're probably the same. And the fourth one, the girl speaks Chinese. Her mother writes poems. This is a bit tricky because it's not using the logic we said like before this question. So let's explain this a bit. The girl speaks Chinese and the girl's mother writes poems. Uh, if you see this example, the house whose windows are open is beautiful. We can say the house is beautiful, and the house windows are open. So this is in the same logic with this question. Um, so we'll say the girl whose oh sorry the girl whose mother writes poems speaks uh, Chinese. And for the last one, a detective is someone, and he discovers the truth about crimes. Yeah, it literally means this, and it's strange that it's strange that it's saying that a detective is someone because we don't usually say that. Um, it's kind of hinting you very obviously. So a detective is someone, and this someone discovers the truth about crimes. So the key question here is to ask you to use the introducing words we said before to refer to the detective, which is someone. Um, so and remember that a detective is someone. So it means that he is a human. So we use who here. A detective is someone who discovers the truth about crimes. And we can, and this is kind of perfect for this question, but I'll expand it a little. Like we'll make it more interesting. Like a detective. Uh, like here we can make an insertion. We can first add two comma, and we insert the short sentence that describes this detective in an interesting way to make this sentence more colorful. Like a detective whose name is Holmes is someone who discovers the truth about crimes. Uh, and also we can make it more colorful here. Like is someone who discovered the truth about crimes that happen um, in his life. So this is to say, uh, his name is Holmes, and he discovers the truth about crimes and uh, the crimes, and what kind of crimes. It's talking about crimes that it's talking about crimes, uh, and these crimes always happen in his life. Um, and we can even continue. like about crimes that happens in his life, um, which has been uh, has been por has been portrayed portrayed by a novelist. So this is to say his life is has been portrayed by the novelist. So this is how relative clause is powerful and interesting here, and it's enough for the grammar exercise for the relative clauses. Alan, do you want to continue?
I don't really have anything else. Do you want me to go over something? Hello?
I think we can just end here.
Yeah.
Are you guys done or something?
Yeah.
Oh, then I can just end